Okay, that being said, we are coming to our last talk of the day and highlights the collaboration between Uber and Alluxio. We've got here is Curt Hu and our own Beinan Wang. Curt Hu is a tech lead manager of the interactive and analytics team at Uber, and he is leading and managing the Presto ecosystem inside Uber. And Beinan is a software engineer from Alluxio, and he is also a committer of the PrestoDB. Prior to Alluxio, Beinan was a tech lead at Presto team at Twitter, and then where he built a large-scale distributed SQL system for the Twitter data platform. He has 12 years of experience working on performance optimization, distributed caching, and volume data processing. He got his PhD in computer science from Syracuse University on the symbolic modeling checking and runtime verification on distributed systems. Many of you probably already asked questions on our Slack channel. Any Presto related question, you can always find Beinan on our Slack. All right, take it away, Curt and Beinan. Thank you.
Yeah, can you guys see my screen?
Yep.
Okay, thank you. All right, so thanks for the introduction. Yeah, in this panel, we're going to have a joint talk with Uber and Alluxio, and we're going to talk about the collaboration on the Presto local caching project. And thanks for that. So with that, let's get started. So first, let's look at, so data informs every decision, and Uber is widely used for Presto and also on all the other query engines. So operation teams doing a lot using Presto to do the dashboarding and kind of things. And the East and the marketplace team is also using this query results to determine the pricing. And we're also using for compliance and the growth market, as well as some ad hoc data analytics. So these slides, we give some very important stats in our internal infrastructure. Basically, we have over 12K monthly active users and over 400K of queries per day, and we're processing over 50 petabytes of data per day. And in terms of infrastructure, we have 2 data centers, around 6K numbers of data worker nodes, and 14 clusters. And one fun factor for this slide is, like, I started modifying this slide from 2018, and I see the numbers growing yearly by yearly very, very much. And yes, from 2016 to now, we basically tax our traffic and internal users. So in this slide, we're going to talk about a little bit about how Presto deployment and infrastructure works inside Uber. So on the top, which is the UI and the client, is basically, we have some internal dashboarding, we have Google Data Studio, we have Tableau, these dashboarding tools, and we also have some background services using either JDBC or other kind of internal query proxying to talking to the Presto. And sitting in the between, it is actually a proxy layout built by our internally. So these proxy will be able to pull in the stats from each Presto clusters and the coordinators. So we got the number of queries and tasks and CPU and memory usage, and we're trying to determine which is the best cluster to go for those query. So basically doing the load and balancing and query gating and sort of, other proxy layout functionalities. And down the line, there's multiple Presto clusters in the different data centers. And through the Presto connector plugins, we're talking to HDFS Hive, and we're talking using P-Node and also some CQ as well. So basically, a lot of query will be able to join on the different plugins and the different external data sets. And in the side, we have monitoring for different kind of layout inside the services, and we also support using Kerberos Security as a security broker. So basically, our workloads is generally break down into the interactive, which is query sending by the human beings like data scientists and engineers, and we also have scheduled query. So those scheduled query we determine as a batch query, which contains dashboarding query and ETL workloads and the vice versa. Yeah. So this page is actually a very simple page, which is just highlighting the point like what we think on the cloud. So over the several years, Uber data team is thinking about like how and when we can go to cloud, and in what kind of layout we are talking to the cloud. So there's a lot of conversation in between, but here's some very abstract points like we can discuss. So basically we're using what, how, and why models. So when we say what, we have different application layouts like, top level like BI and applications. And we also have computing layout and different compute engine, Spark, Presto, and when we're talking about the cloud, there's also different native choices as well. And the storage is also something very important. So right now we are running the HDFS on-prem, and when we're talking to the cloud, there's also different choices whether you can go to GCS, S3, this object store, or we can run even HDFS on the cloud as well. So and why this is also important. So again, there's a lot of discussion on top of that, but on top of our mind is we want to make cost efficiency. We want better facilitate the hardware to achieve the resource elasticity. And we also want to provide high usability, scalability, and reliability. So these are the points we want to go into look at the cloud. And the last one is how we can do that. So there's a lot of things we can talk. And in terms of like a cloud can provide different native features, and how these features compatible with the open source is also something in our mind. And very most important is how the performance looks like in terms of the scale. Uber has holding a very large data lake, and these performance numbers are really important for me and for us and the customers. And also whether the cloud is enforce the security and compliance requirement is also something we are looking at. We can also using the native cloud provided service to reduce our tech debts in our own. Okay, so the next slide is, so this is not something currently in the production. It's more like what do we think, what we are going to be in the Presto going forward. So basically, if you guys look at this graph, we want to really running a hybrid model. Basically, we have prod clusters and cloud clusters. And when we take a look at the storage, we want to vast majority of data is still in on-prem HDFS. But if you look at this blue line here, this is actually we do some testing on top of the HDFS without any caching. So it turns out the network traffic is very high and the cost is also large. So then we want to take a look at what cloud can provide us. So in our mind is basically we want to leverage, either GCS or S3 sort of as a L2 caching layout on top of on-prem HDFS. We want to basically putting some very important or high frequency using the data set into the cloud, serving as an L2 caching layout. And back into each cluster, which is Presto on GCP. So we want to kind of leverage the local SSD cache to caching some data in order to achieve the better performance. So then this solution can be scaled into different cloud providers using this kind of architecture. So we are kind of far away from that, but this is what we think and we want to try to do in the long term. So in the next few pages, I'm going to deep dive a little bit about how we work on the Alluxio local cache with the team and what's the question we're encountering and how we solve that. So in a very high level, the Alluxio caching library is different from Alluxio service. It's a local cache running in the Presto workers. And basically, when any external API read call, basically reading from HDFS call, so we have a wrapper on top of the implementation of default HDFS client. So it will try to look at the inventory of the cache, see whether this is a cache hit or cache miss. And if it is a hit, it will directly reading the data from the local SSD. And if it is a miss, it will also reading the data from the remote HDFS, then caching the locally. Then in the later lookup, we can look up this cache again. So that's sort of the high level how this caching library is working. And some of the key point is the key of this caching is which is the HDFS file path. And in order to achieve the better performance, the cache hit ratio is a very key point. And talk about a little bit about how this working in the Presto, because is there's a little bit of confusion about how Presto can leverage on this. So instead of let the Presto coordinator to actively looking at whether this is caching in the is in the worker or not, it's actually leverage software affinity scheduling for this. So I will deep dive that in the future slides, but basically it's just trying to split the same key into the same worker. Then we'll leverage the local library to determine whether this is a cache hit or not. So that's sort of the very high level architecture of the Alluxio local caching project. So in the next few slides, I'm going to deep dive the problems that we meet and how we can look at this problem and solve this one. So first in Uber, so the data lake is very huge. So as I said, we're processing about 50 petabytes data a day, and our data lake is definitely over the exabytes. And we have different kind of tables. We have hoodie tables. We also have the ETL tables, which is a Hive ETL. So there's a different kind of duplicate files and file change over the time. So in a short word, so mostly our data is partitioned by date, and the hoodie incremental update on different file on each partitions. So basically the same file could have a different version after the hoodie, the incremental update. And for the Hive ETLs, there's a lot of staging directory has been generated, and those staging directory will be deprecated after the new partition has been generated. So it's going to be a lot of redundant data if we don't do something. And also, we're talking about a cache hit ratio. So we have 3+ PB of distinct data access per day, and we have 10% of frequency access data and hot access data. So these frequencies and hot access data is where we are trying to build a graph on how many distinct table access and joint data access for those tables. So the data is huge. So then the solution is like we are trying to building a filter layout to only caching some data which we want. So then we are only going to cache very hot access data in the beginning. Then we can slowly increase the scope of the data caching. And the next one is the HDFS latency. So this graph is generally give you, I guess, idea like during a simple scan filter projection query inside Presto, some of the partition can be very large, let's say split and a task. So from this graph, you can see some of the HDFS latency can over 4 or even 5 seconds, and in the production can even more. So this is can create some random latency from the data nodes, and it can actually be a very key problem of our production query latencies. So when we apply to cache, so the graph looks like this and very good. So the latencies have very guaranteed if this is the cache hit. So by the way, we are mostly making this is into the local cache. Basically, we are trying to guarantee 100% of cache ratio, and you can see the latency is very, very stable and guaranteed. And we also fix a bug of the name node listing. So basically, this is the API that is using by Hoodie, but it has not been overridden in the caching layout. So there's some bug we have been fixed on this. So the next one is back to the slides I'm talking about before, is the software affinity scheduling. So currently in Presto, the software affinity schedule is implemented by the simple mode-based algorithm. And this algorithm, the problem is if there's some chance that the node has been down and up, so then the whole ring has been messed up with the different cache key. So there's already an open source fix to mitigate the dead node, which is basically if you have some predefined nodes, which is a big number, and if there's some internal nodes has some problem, which is less, so then this is going to be solved. But inside of Uber, we have different problems. Is our number of nodes of the cluster is not fixed. This can be shrink and it can be increased. So then we invented some the consistent hash-based software scheduling mechanism. So we have 400 nodes, and each node will take like 10 virtual nodes. It ends up like 4,000 nodes inside this consistent hash ring, and we're trying to distribute all the hash key on top of this. And this also we already sent a pull request to open source, and if you guys are interested, can get it and try to use. So the last page from us is we're talking about current status. So the initial testing is showing very promising results. We see if some of the query is heavily dependent on the SFP performance, it has been improved a lot if the data is in the cache. And we are also in progress to testing SF10K on a TPCDS benchmark. And meanwhile, we are trying to analyze the historical table and partition access pattern, which is hottest data in order to set up the cache filter. And some monitoring and dashboarding is also in progress. So with that, I'm going to hand over to Beinan and talking about the metadata and sort of the concept and challenges of there. So Beinan, hand over to you. Thank you.
Thank you, Curt. Yeah, many thanks for your great contribution. I think the consistent hashing will be a really good contribution to both Presto and the Alluxio community. Yeah, I'm more focused on the work on Alluxio side. When we making the local cache and the Uber's Presto working together, yeah, as Curt side, we are seeing a more faster and also more stable performance on Presto side. But also we are seeing something we really make some improvement on Alluxio side. One is we call the style caching. That means the cache might cache some old data because as Curt said, we are keeping the data on the local SSD of Presto, but the data, the real data, the truth source might be on the GCS, might be on the HDFS. This kind of data might be got updated by someone else. Maybe some other team, they are doing the backfill, or maybe they are just using some hoodie table. We can see some data file actually keep updating. We can see the time step, the last modified time step is keep changing all the time. So if we are cache the old data, that means the result of the query might be not very accurate. And also, even worse, we might see some exception on Presto side because we are keep maybe some new page and also some old page together. And when Presto passing the packet or ORC files, we can see something like offsite invalid exception. Yeah, that's one thing. We are caching the old data. And the other thing is, as Curt side, the working side. I mean, the daily distinctive data read from the HDFS might be huge, maybe more than 3 terabytes. But actually, we cannot have so much cache space, right, for this working side. So that means we need something else. We need the eviction policy. We need the admission policy. As Curt said, they have a cache filter. But also, I think we can also have this quota management. We can put a quota on each table. That means for some really important table or some really hard table, we can have a better or bigger quota. And for some table, maybe it's cold or we don't think it's need to cache, we can put it to a much smaller or even 0 quota on this table. And also, because we already have this kind of metadata in the local cache, but it's just in memory, it's not on the disk. So the metadata cannot be recovered after each server start. That means when something happened, we restart the server. The Presto server will pick up the data, but there's no metadata. So that may mess up the quota management somehow. Okay, next page, Curt. So we propose to make this we call the file level metadata, which will keep the last modified time, also the scope of each data file. We already have something similar in memory, but this time we need to save this kind of thing on the disk. So this one will be picked up after the Presto worker start. Next page. Thank you. So that means after we have this kind of metadata, we may have multiple versions of the data, because if we know that the data got updated, that means we have a newer time step. So we will create a new folder of with the newer time step and keep the newer pages. And then meanwhile, we will try to delete the the older time steps. So in this folder structure on the left side, we can see we have two time step 1 and time step 2. During the server running, mostly it won't happen. We will just keep the time step 2 because we will delete the time step, the time step 1. But during the high concurrent or during the busy server, maybe we cannot delete the time step 1 on time. So at that time, we may keep both the time step 1 and the time step 2. But we keep a metadata file. See the last entry on the left side, we have a metadata which is stored in the protobuf format. It will keep the last time step. We can make sure that our local cache will only read the newer data, the time step 2. It won't touch the time step 1 anymore. And after the server start, it will just pick up the time step, the last time step in the metadata. So it will keep the metadata we need. It won't mess up the content management and also won't mess up the last modified time. Okay, next page. On the other side, because our Alluxio is just a general cache solution, so basically it still needs the computer engine, I mean Presto, to pass in the metadata. So on the Presto side, we have something called Hive file context. For each file, I mean for Hive table or Asperger table or Hui table, whatever, it will have a data file. So Presto will create a Hive file context for each data file, and we will just use this one to open our new file in Presto. And during the open file, we will create a new instance called Presto cache context, which will hold the Hive file context, and we will pass in this cache context to our local file system. In the cache context, we will have the scope, we will have the quota, and also the cache identifier. The cache identifier is just the file path. We do an MD5 on this file path, and the scope is we have 4-level scopes from the database, schema, table, and the partitions. That means if we really want, we can do the content management on the partition level, but most of the time I think we just do the content management on a table level. And within this data, we can do the metadata management, also the stats collection on the Alluxio side. Okay, next page. Yes, as I mentioned, we can do some within this cache context. It's not just pass in the metadata, we can also do some callback to Presto. That means if we are running some query, we can have some insights about what happened, how many bytes hit the cache, how many bytes are not hitting the cache, I missed. I actually read from the external HDFS. So as I said, we passed in the Hive file context within the Presto cache context to the local file system. But the local cache file system will call some callback function. We call it increment counter in the cache context, and this one will continue the callback process to the Hive file context and then to the runtime stats. If you are familiar with the Presto infra, you will see the for a lot of query stats, it's just using this runtime stats to collect the information. And we can do some aggregation here, and in the Presto UI, I mean in the JSON file, we can see this value. We can see the value we updated on the local cache file system. Then that means we have everything linked together, and on Presto side, we will have a better stats. On the Alluxio side, we will have a better insight of the metadata. So that means everything actually that working together. Okay, next page. Then I will talk about some future work, because the last slide actually is still ongoing work. We are still do the performance tuning on that. We are seeing some. I can share. We are seeing some GC issues. We are seeing some GC latency increased because we are using callbacks. We are making the the life cycle of the cache context much longer. Now we are still working on that. And the other project also based on this metadata is we call the semantic cache. We will cache the data structure inside the packet and the ORC file. We will cache the footer and also the strap footer and the index of each packet or ORC files. We will use some more efficient deserialization. It's called flat buffer instead of the proto buffer, because in the ORC file actually they are using the proto buffer to store the metadata. But we found actually the Facebook and us working together on this kind of thing. We found the CPU utilization on the packet footer will be huge, maybe more than 20 or 30% of the total CPU usage. So we planning to use flash buffer instead of the proto buffer to store the caching and store the metadata, which can highly improve the efficiency of the deserialization. Okay, I think that's everything I would like to share today. And now we can enter the Q&A session.
All right, thank you very much for Beinan and Curt. I've got here again Adit, our product and product marketing manager. Take it away, Adit, as a moderator.
Hi guys, hi Curt, nice to meet you. Thanks Beinan and Curt for the talk. I have a couple of questions. One quick question from Slack to begin with. Someone is asking do you also use ETL with Presto? I guess that's for you, Curt.
Yes, so in Uber, we're starting to do that. So right now there's some traffic, but not that much at this moment. Yeah. And actually, our team is also trying to working on optimized packet writer inside Presto.
I see.
Yeah.
Thank you. The second one is a little longer, and Curt, it goes to your future state of the hybrid model that you discussed with compute in a public cloud and your data lake on premises. Okay. I know you mentioned that HDFS is the source of the data, and you plan to use GCS as an L2 cache. And Beinan, during your talk, you mentioned that by having the Hudi file format, there are some strong consistency requirements. So I was curious, Curt, what your thoughts about. First is like, how do you once you use GCS as a cache, like an L2 cache, what implications does it have on consistency requirements for you, and how you plan to handle that?
Yeah. This is a very good question. So when we talk about cache, the biggest question is it is fast, but how it ensures the consistency, right? So right now, when we see our L2 cache, we still need to think about like how we can make our data available in the GCS. So inside of Uber, we have some talking about whether we can use like HDFS disk copy or like some Hive sync tools to sync the data into that. But anyway, there's some SLA guaranteed about that. So if you really look at this problem, so it is actually not ideal like using query engine to understand like as a local cache L1, L2, and on-prem disk, right? So a really bright future is we wish like there's some storage API can build on top of that to serving a single API for the query engine and hiding all this caching layout in the back. And there are definitely some like metadata challenge about it. Like we can use a Hudi and iceberg. So there's a bunch of choice out there. But eventually, let's say if there's some API can abstract in the storage layout with the metadata server, then query engine can just call this API, and the rest of the time is the library or API take care of it, whether it needs to go to local cache versus GCS as a L2, or even go to HDFS as on-prem. So that's some of the thoughts, but that one is also going to take some time in the future. So right now we are looking at see whether we can sort of onboarding some very hottest and important data set to the GCS, and when a query really filed into our cloud cluster, so you need to, so there's some layout you need to determine that which part of the data we need to read from GCS versus join from on-prem. So that's also some thoughts in our mind, right? Yeah. So we also have some insights you can share.
No, I was just curious. So when you described this, Curt, it sounded like you kind of need like an abstraction layer, which is has HDFS, can manage like the cache between local cache, GCS, and HDFS as well. Sounded like something that we should definitely collaborate on with the Alluxio community. So I think we can have a longer conversation. I know you're talking with Beinan, but sounds like a very interesting collaboration.
Yeah, thanks.
One more question related to that, Curt. Since you mentioned the possibility of DCP-based approaches, which are copying data from your on-premise to GCP, what about the granularity that you need for copy? Are you going to? Is it going to be sufficient for you to copy entire files? I know that at some point you mentioned that only 10% of the data is actually frequently accessed.
So unfortunately, this kind of GCS project is still in very, very early stage inside Uber. We're trying to evaluate what's going on there. And, you know, there's also a lot of conversation in the open source world to talking about whether in this massive parallel engine, whether GCS and S3, those object store has the same performance as HDFS. So, and you know, we know that even some companies comparing price per performance of those kind of things. So right now, I don't have some numbers yet, but we do trying to onboard some small subset of data in the cloud to seeing whether those performance comparable with HDFS. But we will definitely follow up with the community if we have some really good numbers here. Yeah.
Thank you. Thank you so much for your time. I know we're already over, so yeah, I think it was. I learned a lot about how you guys are using Presto. I have many more questions, but unfortunately, we're running out of time.
All right, thank you, Ajit, for helping out and moderating, and thank you again for Curt and Beinan for giving such a wonderful talk.